Hello friends, again with the promised video where we were going to explain how to charge the 18650 lithium batteries. As in the previous video, I made an analogy with a glass of water that will correspond to a battery. We are going back to the same system because it was liked a lot and people understood it much more clearly. Here we have a glass of water, well, a glass without water, so we are going to put water. Let's determine. The level is the voltage and the volume of the glass is the amount of intensity or ampere that the battery or cells. As we said that we are going to call a unit a cell and battery the sum of cells as in this case. Here for example, if we had a system of communicating of glasses, two glasses to be able to load, in this sense, each one of the volumes that the glass will have to be filled. In this case, it must be taken into account that to charge a battery or fill a glass, a source is needed that has a higher voltage. In this case, the water level must be lower than the level of water from which we are going to transfer the energy. This larger one comes to represent what a battery charger will be that simple. In a system of communicating glasses, and we join the two glasses from below, like in this draw, we see that there is a communication below and that it will fit this glass. In this case, a battery of 4.2 volts, which will be the maximum level that it reached while charging. Of course, as I explained, the charger has to have a higher level than the level of the battery that we are going to charge. If we are going to charge at 4.2, as the table of specification for this battery says, the charger must be above that level. It can be charged with 8 volts, with 5 volts, with 4.7, but what's going on? The higher the level of the charge generator, the faster it will be, the transfer of which will pass through the other glass. So, what I mean by this? Why? I have made this analogy because I want to explain that a battery charger is just another source that has a higher level, nothing more. There is no more than that. In this case, I can explain the following. You can charge this group of cells, forming a smaller battery with this other group of cells. Why? Because this has a higher voltage and power than this. So if we connect them positive with positive and negative with negative, we will create what will be a communicating glasses system. I insist on saying this because you don't have to focus on the fact that there is only one charger for one thing. The only thing that we need is a higher voltage source to which we are going to charge. We have different models of batteries and source. With this, I can charge it, which is a 12-volt source. I can charge it with this source, which is a source. I can charge it with a 12-volt source. I can charge with a computer source. And I can charge with a source made with a transformer, like this. Of course, if we take out the 220, it must be rectified. There is always direct current. What do I want to achieve with this? Let you see that the charger is nothing more than a high-level source, like the system of communicating glasses. What must be taken into account that the chargers purchased, the serial chargers, have built-in levers. Because if I put a higher source and I don't control the charge, yes, it can damage the battery. So, what can I do? Look for the data sheet that has the battery. For example, this will be the data sheet for a lithium-ion cell. This data sheet has the most important data. I transpose them onto this paper so I could explain it to you. Maximum charging voltage 4.2. In the other video I said 4.1. But because each manufacturer determines a voltage. There are up to 3.9 for example. and the charging voltage on the battery from this data is 3.2. It can be worked below, but it all depends on the manufacturer. In other words, this is the charge range and how far it will be downloaded. The temperature must be taken into account, because it is very important that as we increase the charging speed, the temperature increases and it can't deteriorate. This battery works on this charge from -20 to 60, and in the load from 0 degrees to 45 degrees. These values must not be exceeded, because they are the data provided by the manufacturer, which is the one that guarantees the operation. It is also important to know the ampere hours that can be injected into the battery, because otherwise it will be not accepted. And also, as I said, is just head up in the discharge and in the charge. It is very important to see the datasheet and determine what ampere hours can be used as a discharge. Of course, if we are using batteries in parallel and each one we are going to do an example, each one discharge 1 amp and we need 20 amps. We put 20 batteries in parallel and we are going to achieve a discharge of 20 amps without the battery suffering. The same thing happens. We determine a charge per unit and in turn multiply by the number of batteries that we are going to use. Here, for example, I have another graph. As I always told you, the graphs are informative. They are not exactly perfect, but here we have two curves, one red and one blue. One determines the current and the other determines the voltage. Suppose the voltage is at 0. It rises until it reaches 3.7. It stabilizes for a while and continues to charge, then 4.2 and it remains for a while. That is the tension, but the charging current starts at 0 volts. Go up to 3.4, it remains constant until it reaches 4.2 and then it decreased, although the charger does continue to work. All this is important because I told you that they could load it with any source, whenever it is above the value of the battery to be charged. Let's go back to the example. If I have a 100 volt battery, the source must be above a 120, 130 or 140 volts. Between it's more higher, it's more faster the develop speed. It is essential that the develop speed is related to the data sheet. If we load it very lightly, we will deteriorate it or we will raise the temperature. I do all this application because there are many informative videos about this where they talk about how to apply a charger to a certain battery. With this, I explain to you we are going to achieve it that you have a broad knowledge of how to do it. Also, do you the charger. The most important thing are the controls, because already I said that the battery cannot exceed a certain charging voltage, which is 4.2. So, the famous BMS appears. What is a BMS? A BMS is a charge controller that is between the transformer of the source that I told you is above the value of the battery that we are going to charge. It's in between the two things, because what it manages is to control that it does not exceed 4.2 volts each cells, even though the total is 12 volts, 12.8 the total. Here I have another sheet that is also important. What does the BMS do? Control each cell independently. We can put any number of cells in series and the BMS will have to have as many output as necessary to control each for the cells. Why am I telling you this? Because when one cell charges more than the other, we can run the risk of one being overloaded and the other lacking charge. So the BMS that is determined when one is filling up and when the other is filling up. Here I make another analogy to explain this process. Suppose we have two glasses that will be two batteries. What does the BMS do? Make this. making them have the same level or the same voltage. But sometimes we put together a battery system where the levels, although they are the same, the capacity is different. For example, why do we treat all batteries to be the same? For this reason. Now I am going to explain why it has to be exactly the same. Here we have a battery with a lower capacity than the other. I want to put them in parallel. If I put the same amount of energy into both batteries, now I'm going to add the same amount to the other, because it goes in parallel. Look what happened. This reached the level above 4.2 before. To see it better, this one arrived before, even though it has less capacity. It arrived before, at maximum voltage, than this one. So it is essential that all the batteries have exactly the same capacity, because at the same voltage one can be filled first than the other, and in this sense generates an imbalance that cannot be ensembled when one builds a lot of battery. Therefore, the amount has to be in all cases that we add the same battery capacity. That is why one takes, when building these packs, test how many milliamps, how much does this battery give, how much does this give, and we add the same number of milliamps so that they all reach their maximum level at the same time. This function is done by the BIM-ES, which is a simple charge controller. It's the BIM-ES, it has a lot of cables. If it has a cable for each of the cells to read, if it has more, it stops injecting, if it has less, it injects more, and in turn will be a charge controller. Also, the BIM-ES it does so at the moment of downloading. When it is downloaded, it can also happen that one is downloaded more than the other, and what we are seeing here produces an imbalance. When one was completely downloaded, in this case, the continuity is lost. Now I'm going to show you a BIM-ES like this. It has 1, 2, 3, 4, 5, 6 connections. A connection that is 0 volts, the other, which is the first cells, must have 4.2 volts, the second cell has 8.4, and the third has 12.6. But this is a BMS not only for charging but also for discharging. It has two separate outputs that are called P because it refers to power. Removing the BMS from the power output, what it does when any of the cells are discharged below the critical values, it cut off the entire system. Now, another classic question. I have a BMS for 3 cells, they come for 4, for 5, for 10 cells, but sometimes there is something that others don't say in other instructional videos. Is that you can make the number of cells you want, you have to put BMS for each group. Suppose if I have a 7 cells and I can get a BMS for those cells. I put one of 4 and I add one of 3 for 3 cells and one of 4 for 4 cells. And so we can put the amount of BMS that we want. The BMS of 10 cells are a lot of exactly the same circuits added to the 10 cells that control each of the cells. And one of the cells fails makes the whole chain fail. It is like a chain that has a broken link. When you tighten the chain, that link pops out. I think that with this everything will be more or less explained. It can be improved a little more in another video. There are many videos of this type, but I have said it's as practical as possible so that you understand from the bottom the possibility, because otherwise I will have told you let's buy a 10 cell by BMS, let's put 10 cells, the BMS has to have so many amps, and that is. But this way you understand why. Each BMS has to be related to the amps it will consume. If the BMS is of 20 amps, it's going to consume 20 amps. You can take out 20 amps from it, because if you want to take out 30, the BMS is going to burn out. If you take out 3, the BMS is cool. Absolutely nothing is wrong with it. Well friends, this has been all for today. If you like the video, give it a like. If you are interested, please subscribe. And I am going to show you an electric car. As I say in the previous video, I will try to go step by step. We will going through the BMS for the batteries, then we are going to get to the motors, and we put together an electric vehicle. I already did it, I have done it, and another time I will show it to you. Thank you and see you soon, friends.